Hello there. I'm glad you can make it. My name's Michael Fudge, and this is our Learn to Program series in Java. We're at Lesson 1 right now. Lesson 1 is really going to outline the basics of what a Java program looks like, and we'll take a look at some simple input and output style commands. On the agenda for today is our first Java program, and then we'll take a look at all the pieces and parts that are in a typical Java program, specifically statements and blocks, and commands that accept input and produce output. Along the way, we might throw in a variable or two because you can't do much without variables as well, even though the primary purpose of Lesson 2 is variables. All right, let's get started. As you can see, I have NetBeans, my integrated development environment, up and running, and I'm ready to begin to program in Java. I'm going to start by making a new project. For now, when we make a new project, we're just going to pick Java application. And I'm going to call this particular example Hello World. It's going to generate all the stubs I need for my project for me in NetBeans. And as you saw in the previous screencast, up here in the project area, we have all these different folders and files. So let's discuss these a little bit. Under source packages, this is the code that you write. The code that you write is in one or more Java files. I have one file, Hello World Java. If I wanted to, I can add another Java file under here and it will be part of the same package. The package name is Hello World. When you compile the Java to a jar file, it usually makes one jar file per package. So this package is Hello World. This will make a hello world.jar. I can have multiple Java files in that jar. Down here are the libraries used by this Java program. Right now I'm using the JDK17. That's what I installed. But I can have other libraries as well. I can include additional functionality by adding the jar into this libraries folder. And later on we will do that. First of all, let's talk about these slashes and stars here. These are called comments. These are ignored by the Java programming language. They're just there so that you have reference documentation inside your code. So this is a sample program. What I'm typing is ignored by Java. This line here, package hello world, tells Java that the contents of this file, hello world Java, belong to the package hello world. In Java, every single class, as you see here, it says public class. Each class is in its own file, and the name of the class, hello world, should match the name of the file. If you look here and here and here, they all match. If I change this to hello world Mike, it no longer matches, and then this generates an error that says class hello world Mike is public and declared. It must be declared in a file hello world Mike Java. So I have to rename everything to match. The better way to do that, rather than just edit that, is if I go here, I can refactor and rename this. This is a feature of NetBeans. And I can rename this to Hello World Mike. And then it changes it everywhere where it needs to change it so that it will build correctly. So it says Hello World Mike, Hello World Mike, Hello World Mike. What is a class? Java is an object-oriented programming language. And by object-oriented, we mean you can in code mimic things that you would find in the real world. And these things are known as objects. Objects could be anything from people that you know, or types of people like customers, or maybe they represent physical things like bicycles. Let's use a bicycle example. So, some bicycles have really large tires, some bicycles have small tires, some bicycles are mountain bikes, some are 10 speeds. Those are all different types of objects. In programming, we need a way to categorize those objects, and we do that through a class. We say that this is a public class of objects of type Hello World Mike. That's the best way to explain it. Public means it's accessible by everyone. For now, there's two notions. There's public and private. Private is only accessible internally. Public is accessible anywhere. And then you'll notice after the public class Hello World Mike, we have this curly brace here, and there's always a matching pair of curly braces. These curly braces are known as blocks. They start a block. This says begin the block and end the block down here. So in essence, we're saying define a new class called Hello World Mike, and then this says begin, and then this down here says end. So this down here, this end is really end of class Hello World Mike. This, by the way, these two slashes here are another way that you can represent a comment in Java. Inside every class, we need to have some kind of state and or behavior. So if we want this class to run, we need to have a special behavior called main in here. And this main has three different characteristics. It's public, which we defined earlier. Static means you can use main without defining it first, and this is kind of important when we want to have something that runs without first creating an object from the class. And void means it doesn't return anything. So this is publicly accessible, doesn't need to be declared to be used, and doesn't return anything, and it's called main. And the main method always takes in an argument of strings. So what this says is I'm going to take in strings. These brackets here mean it's an array of strings. We'll talk about that more later. But this says it's going to pretty much take in a list of arguments. We aren't going to use this argument list anytime soon, although it will appear in every single class that we make that has a main method in it. You'll see it always defined the same way. Then if you look, there's a begin and an end, and this begin and end define the begin and end definition for the main method or routine inside the Hello World Mike class. And then in here is where I put my code that actually does something. It says to do code application logic here. So let's make this routine do something. Let's make it print something out. System out print. You can see as I type, NetBeans is suggesting various methods that I should probably think about using. And it does this through these object definitions. So I have system out, and system out is of type print stream, and it's defined as a public static final. Static means it doesn't need to be declared first, and I'm not declaring this, I'm just using it. And then I can look at the methods with a dot, and then I can look at print. Now if I just say print, I have to put what I want to print in quotes. So I'll say hello world, and then that's all I have. I'm going to run that just to show you what happens. And if you look down here in the output, you'll see it says hello world, and then immediately afterwards it says build successful. So one thing you might want to do is print this out and move down a line. So rather than using print, there's another method called print lin, which means print all this on a line. And if you watch the subtle difference between a print and print lin, one way I can show this to you is I could do a print lin, and then I'll do a print instead, so you can see the subtle differences. So see, it first printed out hello world, then it printed out hello world and moved down a line. So if I do I could, kind of mix this up a bit and say print hello and then print world and then move down a line. Run that, and I get hello world all on one line, and then it moves down a line. See, build successful is down here. So that's the difference between print and print lin. If I put print lin here, you can probably guess what it's going to do. It's going to say hello on one line and then world on the next line. We run that. See hello world. Okay, so the important concepts that we have right now is I have to define a class. The class has to match the name of the Java file. Class is contained within a package. The package is defined up here. My entry point for the program that's going to run needs to have a special method called public static void main, and that's here. And then these braces mark the block, the beginning and ending of that method, and then these are the individual statements in the method. Now, a couple other things you'll notice. You don't have to break these out onto lines like this. It just makes it easier to read. I could just move this all and put it all on one line. It would be horribly illegible, but there's nothing wrong with it other than it's hard to read. It still runs the same way. The convention, however, is you put one statement per line. You don't take two statements like these two here and put them on the same line. Even though you could do that, there's no point in doing that, even though you could. You want to break it out so there's one statement per line. Just like every sentence that you type needs to end with a period, every statement that you type needs to end with a semicolon delimiter right there. So the semicolon marks the end of the statement. And you'll notice that when we define a block, that block does not need a semicolon at the end. If I were to ask you a quiz question, how many statements are in this main method, you would say there's two statements, 1, 2. If I were to do it this way, and say how many statements are in this main method, you would still say there's 2 statements, 1, 2. Because the line doesn't define the statements, the semicolon defines the statement, the end of the statement, that is. Okay, let's continue on and kick this program up a notch by defining a variable. A variable is a named piece of memory that you can assign values to of a specific type. So I want to use strings, and strings are represented like this. This is a string, Mike. And I have to give my variable a name, so I'm going to call this your name. That's going to be the name of my variable. And so this statement says, please set aside a piece of memory called your name, and it's going to hold data of type string. And then I can assign a value to your name, like your name gets the value Mike. And then last but not least, instead of saying hello world, why don't I say hello your name? If I say hello your name like this, it's going to say the literal your name. But if I wanted to say what the value of the variable is, I leave the quotes off, because the quotes define something to literally print. Whereas when I do it this way, it's saying use the contents of this variable, your name. So when I run it again, now it says hello Mike. Pretty cool. Now let's get this fixed so that it goes back to using one line. So I'm going to change this back to print, like that. And then I also want to print out those exclamation marks. So system out print line. Then let's throw out some exclamation marks like that. And then I'll change this back to a print again. And I think now I have what I wanted. You can see my program's getting a little big. Move this down. Let's run that. Now I have hello, comma, Mike, exclamation mark, which is what I wanted. Perfect. What's going on here? This first line inside my main method, line 10, is saying set aside a piece of memory. I'm going to reference it by this name called your name, and it's going to hold strings. And then this second line of code, line 11, says take this literal value, Mike, and place it in this variable called your name. So it's going to write it into the memory. And then these 3 lines do exactly what you think they do. This prints hello, this prints out the value of your name, and this prints out exclamation marks. It should be noted that lines 10 and 11 here happen so often that there's a shorthand method for it, and we usually end up writing it like this. Now line 10 declares the variable, your name, and then also assigns a value to it to start. And this is a pretty common pattern that we'll use often in Java to initialize our variables or give them starting values. Okay, let's take this program to the next logical step. I think what makes the most sense at this point is to write a program that asks us to type our own name in and then says hello to us based on what our name is. To do that, we need to accept input from the user. Now, there is a system in, just like there's a system out in Java, there's a system in, but it's a very raw method of accepting input. So what we're going to do is we're going to leverage an existing package that's out there in the Java libraries. So I'm going to type in scanner, and I'm just going to give this scanner, which is a type, I'm going to give it a variable called input. And then this type of class needs to be declared. So I'm going to say equals new scanner input equals new scanner. And to make a scanner, you need to pass in system in, because I want to grab the input and use the scanner class. Now when I do this, it has an error, and this error says cannot find symbol class scanner. And the reason this is because we did not pull in the package that we need. So what I need to do is come up here and type import, which will allow me to pull in the package that I need. It's java.util.scanner. If you're just typing this up in Notepad or whatever, you have to remember, the thing that I need to use, scanner, comes in this package. The nice thing about using a product like NetBeans is I get this error here, and it says Alt-Enter shows hint, Alt-Enter, and it says add import for Java util scanner, and I click there, and it adds the statement up here for me. So the IDE, NetBeans, is smart enough to figure out what I meant to do and then suggest ways that I can correct my own code. This is a good thing. it sure beats trying to remember which package contains which class you need to use. Going back on the class object idea, and this is something that we'll talk about in a couple of weeks. The name of the variable is input. That's the object. The name of the type of the variable is scanner. That's the class. So I made an input object of type scanner, and I'm defining that as create a new object of type scanner using system in. That's what this statement says. We'll talk about this more in a couple of weeks. Important thing to know is that when you need to grab input, you always need this line. Now we can go ahead and finish out our program. We can say system out print what is your name. Then let's get the input. Let's say string your name, and then rather than hard code in Mike, let's say your name is input dot get the next line. So everything up until you enter, press the enter key. And let's give this a run. So now it says, what is your name? Well, I spelled your wrong. That's fantastic. And I'm going to put in Tony. And now it says, hello, Tony. And then I'm going to run it again. Let me fix your because that looks dumb. What is your name? Mike. Hello, Mike. Cool. Well, the last thing I'm going to do before I let you have at the debug this and challenge activities is I'm going to show you another form of print. There's print, println, and there's also printf. Printf allows you to really customize how things get printed. So what I want to do is I want to say hello, and then I'm going to print some string, and then I'm going to print a bunch of exclamation marks, and then a new line because I want to move down a line. And then the argument that I want to replace this string with is going to be your name. And then I can get rid of all these other prints. So now my program's a little cleaner. It says print out using formatting. I wanted you to print out a hello, a comma, a space, and then some string, which I'm going to give you in a bit, and then print out a bunch of exclamation marks, then print out a new line. That means move down a line. And then replace this %s with the contents of the variable your name. So if I run this, it gives me the same output. What is your name? Ginger. Hello, Ginger. And there you have it. Well, that concludes our first lesson on learning to program in Java. I encourage you at this point to go out and try the debug this and challenge activity exercises. Those activities will help you master the things that we learned in this first screencast. I look forward to seeing you again at the next screencast, and thank you very much for watching. Please, if you have any comments or feedback, post them on YouTube. Thank you. Bye.